All right, greetings everyone. The purpose of this video is to go over another example of finding the equation of a logarithmic function given its graph. So we're going to work with this function here that you see on the screen that I'm going to call f of x. And first things first, I know this is a logarithmic function because if I look here at like x equals 7, we have a vertical asymptote. So because this is a vertical asymptote instead of a horizontal one, that tells us this is a log. And then we also have to decide which of our two formulas for the equation of a log function that we need to use. Now, since this function shoots off to the left, so notice that the tail there is going to the left side. This means this is a reflected log function, which means we need to use the general formula for a reflected log function, which would be this one. So f of x equals a times log of negative of x minus b plus k. Okay, and so we need to find in this the values of a, b, and k. Now the first one, to find the value of b, is fairly straightforward. That's going to come from where the vertical asymptote is. So since that's at 7, we know the value of b is 7. So we can start by writing our equation as f of x equals a times log of negative of x minus 7 plus k. So we are now well on our way to finding the equation of this log function. So our next step is to work to find the values of a and k. In order to do that, we need to identify 2 points on the function. And as we do this, we want to try to identify points that are easy to read, or that the coordinates are straightforward. So 2 such points that I see in this one would be at 5, negative 3, so right there, and then also at, looks like right here, at negative 3, 1. Okay, so I'm going to use those 2 points to help me find the values of a and k. So what I'm going to do is plug those in, those 2 values as our inputs and our outputs, into the equation. And I'm going to have to do this twice. So I'm going to start with the first one, the 5, negative 3. So the 5 is the input, the negative 3 is the output. So negative 3 will go in for x, the 5 will go in for f of x. So when we set this up, sorry, trying to find a good color. What this will end up looking like is we'll have negative 3, since that's the output, equals a times log of negative. Then we plug in the input value, which is 5 minus 7 plus k, since we don't know what that is. And then we'll do a similar process using the other point, the negative 3, 1. So when we do that, plug in those points. So we'll have 1, since that's the output, equals a times log of negative, plug in negative 3, since that's our input, minus 7 plus k. All right. So now we're going to go through and simplify these. So what we'll do is on the top one there, can simplify what's inside the log there. So of negative of 5 minus 7 So let's see, 5 minus 7 is -2, and the negative of that would be +2, so this would become -3 equals a times log of +2 plus k. And then for the second one there, we have -3 minus 7, so -3 minus 7 is -10. We have the negative of that, which would be +10, so this becomes 1 equals a times log of +10 plus k. And then something nice has happened here with the log of 10. Now I should say this will not always work. And in fact, you know what? I think I'm going to leave it as is for right now. But just notice that log of 10 would just be 1, right? And so this would really become a times 1 plus k or a plus k. But I'm going to leave it as is to make a point. So now what we want to do is we have two equations with two unknowns. We have -3 equals a times log of 2 plus k, and 1 equals a times log of 10 plus k. And so what we need to do, because we need to solve for the values of a and k, is isolate one of the variables in one of those equations, and then plug it into the other one. Okay? So I'm going to start by working with the top one here. The -3 equals a times log of 2 plus k. And what I'm going to do is, since the variable k is by itself there, I'm going to isolate that. So in order to do that, I'm going to subtract a times log of 2. Okay, since that's being added to the k, I'll subtract that on the left-hand side too. And so when we do that, they'll cancel here. And so we just have the k on the right-hand side. On the left, we have -3 minus a log of 2. Those are not like terms, so we can't combine them. So we'll just leave that as -3 minus a times log of 2. And notice now that we have k equals this. So since k equals that, we can take that and plug it in for the value of k in the other equation. So we'll go ahead and do that. So that second equation now will become 1 equals, and actually I'm going to need to write it lower because I'm going to run out of space here. Okay, so the second equation now, when we go to write it with the value of k plugged in, will be 1 equals a times log of 10. And then instead of k, I'm going to put in the value here that k is equal to. So -3 minus a times log of 2. Okay. And now notice, even though this looks really complicated, we have an equation that only contains one variable, the variable a. And so what we want to do is work to isolate that. So first things first, notice that that -3 there doesn't have a variable with it, so we can move that over to the other side of the equation. So I'll add 3 to both sides. And so when I do that, I end up with 4 now equals a times log of 10 minus a times log of 2. And on that right-hand side, things might be looking a little dire because we have a in two separate terms. But because it's in both of those terms, okay, there's an a here and an a here, we can actually factor it out. So this becomes 4 equals a times, and if we look at what's left over, right, in the first term when we factor out an a, we're left with log of 10. Minus, in the second term, we're left with When we factor out the a, we're just left with log of 2. Okay. So now we have 4 equals a times log of 10 minus log of 2. And we can actually simplify this a bit further. I'm going to go up here. Because notice we have log of something minus log of something here. And if you remember from our log rules, when we have log of something minus log of something, we can write that as log of the quotient of those two, or them being divided. So this would become 4 equals a times log of, again, the first something divided by the second something, so 10 divided by 2, which in this case would be 4 equals a times log of 5. Which we can then now solve for a by dividing both sides by that log of 5. And I'm sorry, this is getting really messy, but we end up with now the value of a, oh gosh, I'm going to have to write it down here, equals 4 over log of 5, which we can then plug into our calculators. When we do that, we end up with 5.723 as the value of a. All right. Now, we're not quite done because we still have to find the value of k, right? Because we found the value of a and b, we need to find k. And we don't have to go back through this big long process because right here in the middle of our page, we have a formula for k in terms of a, right? So we have that k is equal to -3 minus a times log of 2. And so we can just plug in the value of a there to find the value of k, which I'll do on the next slide. I will say when we do that, to save us rounding errors, I'm actually going to use this exact answer here, the 4 over log 5, just so I don't end up with any issues there. So let me show you on the next slide how that will look. So again, we have that k is equal to -3 minus a times log of 2. As I mentioned on the previous slide, we found the value of a was 4 over log 5, so I'll go ahead and plug that in. So I'll have -3 minus. In the place of a, I'm going to put 4 over log of 5 times log of 2. And be careful here, you cannot divide the 2 and the 5 in this case. Even though that 5 is on the bottom there, it's because it's log of 2 divided by log of 5 in this case. So we can just plug that into our calculators, all of that. So I have -3 minus the 4 divided by log 5 times log 2. In this case, I get -4.723 is the value for k. And now with that, we found the values of a, b, and k, so we can write out our final equations. So remember again, our formula we were working with was f of x equals a times log of negative of x minus b plus k. And again, we found the value of a to be 5.723 times log of negative of x minus, the value for b was 7. And then plus the value for k, which in this case was -4.723. That's our final answer. Okay, thanks for watching. That's it for now.